Okay, folks, so today we're going to be talking about quadratic functions and vertex form. This video is going to assume that you already know something about quadratic functions. For example, I am going to assume that you already know that a quadratic function always produces a U-shaped graph. In our case, it's usually pointing either up or down when it comes to the kind of math we've been doing. This is known as a parabola. Okay? The other thing I'm assuming that you remember is that quadratic functions always have a degree of 2. For example, as you can see there, it says y equals x squared plus 5. A quadratic function will always have a little 2 as the exponent somewhere in that expression. And if there was a 3 or a 4, then it would not be a quadratic function anymore. It would also not be a quadratic function if it was just y equals x plus 5. Okay? That is actually a straight line. It is not a parabola. And so as soon as you put the little 2 there, suddenly that squared will turn this thing into a quadratic function or a parabola. Okay? So those two things I am going to assume you already know. So let me clear out that stuff. All right. Today we're kind of focusing in on one specific form of a quadratic function. It's called vertex form. Okay, and it looks like this right here. This is kind of the basic form right here. We'll be concerned with what A, what H, and what K do. So as you'll see on the next screen, they all have a role to play on what the parabola is going to look like. Okay, so with that, let's go to the next page. And when we're given a quadratic function in this vertex form, which we're going to see how it works in just a little while here, we want to ask these questions. What does changing a, h, and k do to the parabola? What if we change the signs of a, h, and k? So what if we make them negative or positive? Okay. And number 3, how easily can I identify the vertex if I have a parabola in this form? The cool thing is the vertex is really easy. When you have a vertex form, finding the vertex will be very easy. Okay? I'm going to skip over here, and I don't work for Desmos, but I want to tell you that this particular company, Desmos, or these people, they made an amazing calculator. I'm going to click on here just to show you it. This is what it looks like online. They also have, oh boy, I just messed it up. I'm going to get it back. Here it is. They also have an app that you can get on your smartphone, and it's free, and it's fantastic. You can do all this stuff right from your own phone, okay? Big plug for Desmos. It's great. Okay. So let's talk about the most basic parabola that I can think of. I call it the mother of all parabolas. And that is y equals x squared. And there it is. As you can see, it's a parabola. And it's going up from the vertex here. This is called the vertex, as you might remember. And this one's at 0, 0. And it's going, left and right in this form right here. What happens if we make some changes to this parabola? So what if I was to make y equals negative x squared? What would happen? If you remember, it just makes the parabola turn upside down. There it is. It's flipped. Okay? Let's do some more stuff to this parabola. What if I was able to make it what if I put a 3 or a 2 in front? Okay, as you can see, the parabola got skinnier. If I put a 3 in the front, it gets even skinnier. In fact, I can show you really easily. If I put an a in the front, it lets me put a slider. This is such a cool graphing calculator. Now watch what happens. Right now, a is 1, as you can see right here. If I increase a, the bigger the number, the skinnier or the more stretched vertically the parabola gets. Okay? And I'm going to go down. As soon as it is 0, it's a straight line going across at 0. As soon as it's negative, it's upside down. The bigger the negative number, notice the number's getting bigger, the skinnier the parabola gets. Okay? So negative 6, that's a pretty as far as negatives go, I guess you could say that's a pretty big number, or you could say it's a very small number. Depends how you want to think of it. But a 6 with a negative sign in the front is going to be a very skinny parabola pointing down. Okay? Let's go back to our parabola here, and let's see what would happen if we were to do this. I might as well just delete that and go, sorry. Okay, x minus 2 squared. There. Do you see what happened to the parabola? The original parabola is red here. Here, let me make it even thicker so it's easier to see for you. Projector mode. Check that out. Okay, the red parabola is our original parabola, and the blue parabola is what happened when I just typed in x minus 2 in brackets squared. Do you see what happened? The parabola shifted to the right 2 places. What would happen if I changed this 2 to a 3? Well, you're probably saying to yourself exactly what's about to happen. It shifted over three spaces to the right. Kind of cool, hey? I want to show you something else. I'm just going to put a 1 here. It's shifted over 1 to the right now. Well, I'm going to put a plus here instead of a minus. Most people would think plus is going to the right and minus is going to the left, but with parabolas, once they're inside brackets, it actually does the opposite of what you would think it would do. So I'm going to put a plus 1 there. Look at the parabola in blue. It has moved 1 place to the left. It's the opposite of what we thought. Okay? So if I make this a 2, it goes 2 to the left. All right? So I just wanted to show you that, well, here, I can even do the slider thing. Remember how I put the A before? I can use a slider. Then you can watch the parabola go. Okay? The bigger the number above 0, the more positive it is, the more left it goes. It's kind of the opposite of what you'd think. Okay? And as soon as A is negative, it starts going to the right. Okay? This is something my teacher could not do in high school on the blackboard. So I'm very lucky to be showing you this today. And thanks to the Desmos folks, I'm able to do that. Okay. One more thing we wanted to talk about is what happens when you put a number on the very end, after the squared part. So let's say plus 2. See what happened to the parabola? It moved up 2. There's no weird stuff going on here either. The plus 2 really means it goes up 2. Okay? And if I go plus 1, it's up 1. If I say 0, well, it's right at 0. But if I say minus, let's say minus 2. See, the blue parabola went down 2. Okay, I think you get the idea. Of course, if I want to, I could put plus A and then make a slider. You can do this on your own phone if you want to. See that? You can make the parabola go up and down. Okay? The parabola is not changing shape when I move it left or right or up or down. It's not changing shape at all. All it's doing is moving around. Okay? So let's go back to our other screen here and just remind ourselves what's going on. Okay, let me point to these various things. When you change the A value, you change how skinny the parabola is. Okay? And in textbooks, they don't use the word skinny, okay, or wide. What they would say is they give a vertical stretch, or some textbooks may use the word compression, okay? So if it's really skinny, somebody might say it's been stretched vertically by a factor of 3, okay? By the way, a parabola really compresses or widens when you put a number here between 0 and 1. Let me show you that on the Desmos again here. So what if I were to put, let me get rid of this blue one. What if I put a 1/2 in front of x? Watch what happens to the parabola. See how it got wider? Okay, so some people would say it's been vertically compressed by a factor of 1/2. But I'm really open as a math teacher to however you want to say it. You might just say it's vertically stretched by a factor of 1/2. You don't necessarily have to say compressed in my class, okay? It's up to the teacher though. You have to make it clear to whoever's marking because they're the ones giving you the marks, right? But as long as you can communicate what's going on, that's the important part. Okay, so I'm going to go back to this screen again. Here we go. All right. Now, if you put a negative sign where the a is. So if you put a negative sign in front of the a value, what you're going to get is a parabola that goes down or points downward. Okay? So what we're going to do is we're going to move the h. If we change the value of h, that's going to move the parabola left or right. So if h is negative, it's going to go to the right, and if h is positive, it's going to go to the left. Exactly the opposite of what you might think. Okay, the last one we talked about was k. K, as you remember, it moved the parabola either up or down. And if it's a plus 5, it's going to move up 5. If it's a minus 5, it's going to move down 5. Okay? I think we've basically covered everything that we wanted to say except for one thing. Let's say I typed in this equation. I'm going to make one up right now. Let's make it fairly simple. Let's say x minus 3, and that's x minus 3. I want to put a squared on it because if I don't put a squared, then it's not a parabola. And let's put a, I don't know, a plus 2 on the end. There's the parabola. Look at that. Two things have happened to it. Do you remember those two things? Look over here. The parabola has moved to the right 3, and it has moved up 2. Let's check it out back over here. I can bring this over. Heck, we can even zoom in. See if we can get more numbers showing. Look at that. The parabola has moved to the right 3, and it has moved up 2. Okay, and there it is. This point right here is called the vertex of a parabola, and I want you to look at the vertex right now. Do you notice something about the 3 and the 2? Okay, go back to this equation here, and look at that. The 3, the negative 3, well, that is where this 3 came from. You just change the sign. This part's always lying to you inside the brackets. It's always the opposite of what you might think it is. So if you see a negative 3 here, you know that the x part of the vertex, this is the x part, is 3. And see the 2 on the end? You just throw that on the y part of this coordinate pair here. So you got a 3 and a 2. Let's put another number in. Let's put in a 4 and a 1 on the end. What would the vertex be without even looking at the graph? Well, you guessed it. It would be 4, 1. The x would be 4, the y would be 1. Okay, let's change things around here. Let's do one more here. What if I said x plus, this is going to be a tricky one, x plus 2, and let's say, heck, let's be tricky here. Let's put a minus, whoops, I didn't want that. I want a minus 1 there. I gotta get rid of this little thing here. Oh well. I don't know how to get rid of this part. There we go. Oh shoot, it's still there. I wonder if I can edit this out. There we go. Okay, I got it. Whew. So here we have it. Do you notice that the vertex is the opposite sign of what you see in the brackets? So it's negative 2, minus 1, or negative 2, negative 1. And here, over here is the vertex. Okay? So you can see how the vertex form of a parabola is really, really quite easy. If somebody says, what's the vertex, and you see it in vertex form, you literally just have to look at the h and the k, change the sign of the h, whatever it is, take the opposite sign, and the k, take the k just as you see it, and you will have vertex form, and you'll have the vertex as well. Do I need to talk any more? I don't think so. You could always push rewind. And I think you know all about the signs. I think we've covered all our bases. I see one more question here in the corner, though. I almost forgot. Can Desmos draw the axis of symmetry? What is the axis of symmetry? Well, I'll just let you know quickly on paper here. Let's see. I'm going to get a pen. I'm going to draw a parabola. Let's say you had a parabola that looked like this. And this was the vertex right here. The axis of symmetry is a line that slices right through from top to bottom. And it's a vertical line. My drawings are never that great. But it's a line that cuts through from top to bottom. It cuts this parabola in half. That's the axis of symmetry. It cuts through the x part of the vertex. Okay? So it cuts through at this h value right here. Okay? And that is called the axis of symmetry. Sadly, it's like a butterfly on a science lab and someone has stuck pins in it and maybe even had to dissect it and maybe cut it in half. That's a terrible way of describing the axis of symmetry, but maybe it will stick in your mind better. Can Desmos draw the axis of symmetry? Why, I'm glad you asked. Let's do that. What it's going to be is an equation, not starting with y, it'll be starting with x, and you type in the x value of the vertex, which we can see right there is -2. So I'm going to do that. And as you can see, there is an axis of symmetry drawn right in there. Can you all see it? Heck, if you wanted to change the axis of symmetry, you could even adjust. You know how I had a dotted line? There we go. You can turn it into a dotted line. Desmos has it all. Boy, they should hire me as a I guess it's free, so it's not like they can hire me. But anyway, Desmos is a fantastic graphing calculator online, and also on your iPhones and your Android phones. It works all those types of smartphones. Okay, folks, that's about all I had to say today. Hopefully this wasn't too long. I'm going to try and stop this video right now. Have a good day.